Our lesson on 9.6 is all about solving rational equations. So this time, instead of having just a rational expression, we're going to end up with something that has an equal sign in between two parts. So just as a review, back in chapter 1 when we had an equation that looked like this, if you remember, we'd put big parentheses around the whole equation, we'd look at our denominators, which were 3 and 4, and we'd come up with the LCM of 3 and 4, which would be a 12. Now the reason we did this is because when we went ahead and distributed the 12 to everybody, we created a linear equation that no longer had fractions. So 12 times x over 3 gave us a 4x. 12 times 5 gave us a plus 60. 12 times 2/3 gave us an 8x. And 12 times negative 1/4 gave us a minus 3. Now we could solve this very quickly if we just go ahead and subtract the 4x over here and add the 3 over here. So 63 equals 4x. And x came out to a gross answer, but easy work, 63/4. We're going to apply the same concept to our rational equations next. So let's look at our first example. Number 1, big parentheses around the whole equation. If I look at my denominators, I have an x and a 3x and a 3. Well, the LCM of those would be the expression 3x. Now when I go ahead and I distribute the 3x into the first fraction, 3x times 7 over x, if you notice the x's are going to cancel, leaving you with just 3 times 7, or 21. Notice I do not have a denominator anymore because the x canceled. The next fraction, 3x distributed in, is going to cancel with the other 3x on the denominator, leaving you with just a minus 1. And then 3x to the last fraction, the 3's are going to cancel, leaving you with just 5 times x, or 5x. Now we end up with a very easy to solve linear equation. 20 equals 5x, so x equals 4. Moving on to example number 2. The first thing I notice is that this denominator is secretly an x plus 2 and an x minus 2. Just like when we did adding and subtracting, you're going to want to factor all your denominators so you don't do too much work. Big parentheses around the entire equation. We're going to put an x plus 2 and an x minus 2 outside. Whoops, that's supposed to be minus 2. Now, when I go ahead and I distribute the x plus 2 and the x minus 2. In the first fraction, I hope you notice that the x minus 2's are going to cancel out. So you still have a 3x, and he's still going to be multiplied by the x plus 2, but not the x minus 2, it was canceled. In my next fraction, I hope you notice the x plus 2's cancel, leaving you with just x minus 2. And then in the last fraction, everything cancels, so you're just left with a minus 4. We're going to clean this up a little bit. We're going to distribute the 3x and get 3x squared plus 6x, there's still a plus x and a minus 2, equals negative 4. I notice I have a big quadratic here. It needs to be cleaned up quite a bit. Bring everything to the left-hand side and combine your like terms. So 3x squared plus 7x plus 2 equals 0. And then using our factoring skills, let's see, this factors into a 3x and an x. Let's see, add up to a 7. So how about a plus 1 and a plus 2? And that works because we have a 6x and a plus 1x gives us a 7x in the middle. So my two answers I get when I solve these two binomials is a negative 1/3 and then negative 2. Unfortunately, we are not finished. If you notice, up in the original problem, we have denominators. Now look what would happen if you plug in a negative 2 into, say, this denominator right here. Negative 2 plus 2 would give me a 0, and as you know, we cannot divide by 0. So what we're going to do is we're going to cross that answer off, and we're going to write ext, because this is called an extraneous solution. Algebraically it shows up, but it doesn't actually work for the problem. X equals negative 1/3 does work. We're going to keep him. Show your teacher you got negative 2, cross it off, write extraneous, and you'll get all your points. The next example, big parentheses around the whole thing. Just x plus 3 is our least common multiple. So when I distribute that to everybody, the first fraction is just going to end up being a 2x. The next fraction has a negative 5, and since there is no denominator to cancel, he still is going to have to be multiplied by the x plus 3. And then in the last fraction, the x plus 3's cancel, leaving you with just the 1. Go ahead and distribute the negative 5. And when we collect our like terms, we get negative 3x. If I add the 15 over, I get equals 16. And not the greatest answer, but it works. Negative 16/3. Now that I know about this extraneous issue, I look at my denominators. The only thing that would have created an extraneous solution would be if I plugged in a -3, which is not the answer I got, so I'm going to move on. Okay, big parentheses are on the next problem. My denominator is an x and then a 3x, so my least common multiple of those would be a 3x. I'm going to go ahead and distribute that into the first fraction. The x's cancel, leaving me with an x, or 9, excuse me. And then 3x times 12 is plus 36x. 3x times 2 is 6x. And then in the last fraction, the 3x's cancel, leaving you with a plus 4. Now we have a simple linear equation. I'm going to subtract the 6, and then subtract the 9. Now be careful here. You know, a lot of kids dividing upside down. You're going to divide both sides by a 30, leaving you with the answer x equals -1/6. And we're finished. Again, denominator, the only thing that would give me trouble is if x equals 0, which it doesn't, so I'm moving on. Next part, oh, easy. X plus 1 is our least common multiple. The x plus 1s are going to cancel in the first fraction, leaving you with a 5x. The next number does not have anything to cancel with, so it's going to be 4 times the quantity x plus 1. And in the last fraction, the x plus 1s will cancel, leaving you with a -5. Let's go ahead and solve this. It doesn't look too bad. 5x equals 4x plus 4 minus 5. Combine your like terms, and now we get x equals -1, but don't stop there. Look what's going to happen in either one of these denominators. If you were to take that -1 and plug it back in, it would give you a 0 denominator. So it turns out this is actually an extraneous solution, and since I have no other working solutions, this problem has no solution. Haven't seen that yet today. Okay, next problem, big parentheses around the whole thing. My least common multiple of this equation is going to be a 2x. I'm going to go ahead and distribute into the first fraction. The x's cancel, leaving us with 2 times 3, or 6. In the next fraction, the 2's cancel, so -1 times x is minus x. And in the last fraction, the x's will cancel, leaving us with a 24. So we get -x equals 18, or x equals -18. And again, I check for extraneous solutions by looking at my denominators. That's not going to give me any trouble, so I'm moving on. Okay, we have a secret denominator here. X squared minus 1 is really an x plus 1 and an x minus 1. So when I think about my least common multiple for my denominators, come on, pen, work for me. All right, computer's frozen. We're going to multiply everything by an x plus 1 and an x minus 1. Sorry for the sloppy handwriting. So in the first fraction, we still have the 5x. His x minus 1 canceled, but we do have to multiply him by an x plus 1. The next number does not have anything to cancel, so I'm going to go ahead and multiply him by the x plus 1 and the x minus 1, but I'm going to cheat. I'm going to FOIL those back together and say x squared minus 1, because I know I'm going to have to distribute this -2, so I'm just saving some space. And then in the last fraction, the x plus 1 and the x minus 1 cancel, so you just have a 14. When I go ahead and distribute that 5x, oh no, we got a quadratic, 5x squared plus 5x, and when you go ahead and distribute the -2, you get a -2x squared plus 2, be careful there, equals 14. Since this is a quadratic, we have to bring everything to the left and set it equal to 0. So we have 3x squared plus 5x, and when I subtract the 14 over, I get a -12 equals 0. Now this one might take you a couple tries to factor it, but it's not that bad. 3x and x. Let's see, how about a -4 and a +3? I think that works great. So when I go ahead and solve these, I get x equals +4/3 and x equals -3, neither of which will give me extraneous solutions because of the denominator, so we are good to go. Those are our answers. In the next example, big parentheses around the whole thing. We're going to multiply everybody by an x, leaving us with nothing cancels in the first, so x squared minus 24, because the x's cancel, equals a 5x. And this doesn't look too bad, but it is a quadratic, so you need to set it equal to 0. And then factor and solve. And this is one that could be done through a diamond, because the coefficient is a 1. So it's got to multiply to -24 and add up to a -5. So how about a -8 and a +3? So when I go ahead and solve those two factors, I get x equals 8, and x equals negative 3, and those are good. Ooh, yuck. Our last denominator here is definitely factorable, and the way these problems usually work is that some other piece of the rest of the problem are factors of the most disgusting looking denominator. So I'm going to go on a wild limb here and assume that this guy factors into 3x plus 2 and x minus 2. I'm going to double check it by foiling real quick in my head. 3x squared minus 6 plus 2 would give me the negative 4, and then 2 times negative 2 gives me the minus 4. So we are good to go. Big parentheses around the whole thing. We're going to multiply everybody by a 3x plus 2 and an x minus 2. So in my first fraction, the x minus 2's cancel, so you have a 2x still times 3x plus 2. In my next fraction, be careful, there's a negative. Now we talked about this in the last lesson. When there's a binomial numerator, he's actually in parentheses. So the 4x minus 1 in parentheses is still going to be multiplied by an x minus 2 because his 3x plus 2 canceled with the other 3x plus 2. And in the last fraction, everything cancels down there, so we just have a 17x plus 4. Okay, big, ugly quadratic. We're going to go ahead and distribute the 2x, so 6x squared plus 4x. And now I'm going to keep the negative in front. I'm going to quickly foil this FOIL problem together. So 4x squared, let's see, minus 8 minus 1 is minus 9x, and then plus 2 equals 17x plus 4. Now I'm going to go ahead and distribute the negative. 6x squared plus 4x minus 4x squared plus 9x minus 2 equals 17x plus 4. Ugh. Now, a lot of things we can collect. I'm going to bring everything to the left and collect my like terms. So I have 2x squared. Okay, let's see, that's a 13x. When I bring over the 17 by subtracting, we get a minus 4x. And then negative 2, bring over the 4 by subtracting, and get a minus 6 equals 0. Now before I start factoring, I notice everybody here is divisible by a 2. So I'm going to change that to an x squared minus 2x minus 3. Much better to factor. And you end up with, excuse me, x minus 3 times an x plus 1 equals 0. So my two answers are x equals 3 and x equals negative 1. And I do a quick double check on my original denominators. Are either one of those going to give me any issues? Divide by 0? No, they are not, so we are good to go. The next set of problems are just a fraction equals a fraction with no addition or subtraction in between them. So we're going to use our technique from Algebra 1, which is just cross multiplying. So if you remember cross multiplying in Algebra 1, just drawing your butterfly wings, and you have to be careful here because there is some distribution. So we have 2 times the 2x plus 3 for the first diagonal, and then 2 times the x minus 5 for the second diagonal. Now, you might notice that the 2's are going to end up canceling out, but if you didn't, that's okay. You're going to distribute and get 4x plus 6 equals 2x minus 10. And then when you collect your like terms, 2x equals negative 16 and x equals negative 8. Just like in the last set of problems, you got to be careful that your answer does not give you a 0 in either of your denominators, and it doesn't, so we're moving on. The next problem, when we go ahead and cross multiply, it doesn't matter which one you do first. I like to do the one that's going to be my lead coefficient though, and I notice this will have an x squared. So it's going to be x times x minus 1 equals, the other diagonal would be 2, sloppy, times a 3x minus 5. And let's go ahead and distribute that. X squared minus x equals 6x minus 10. It is a quadratic. We're going to bring everything to the left. X squared minus 7x, and then it'll become a plus 10 equals 0. Oh, I'm sure that factors pretty easily. So how about a minus 5 and a minus 2? So my two answers are x equals 5 and x equals 2. Again, you check for extraneous solutions. I think we're both good on those. Number 12. Again, you're going to cross multiply. This one's a little messier because there's quite a lot of foiling. So 3x minus 1 times a 4x minus 13 equals 2x plus 5 times the quantity 6x minus 2. So when I go ahead and FOIL this, this gives me a 12x squared, let's see, minus 39 minus 4. So did I do that right? So that's a negative 42x, and then a plus 13. And then again, 12x squared, that's actually good news because those are going to cancel. Let's see, plus 30 minus 4, so that's a plus 26x. That was not 42, excuse me, that's 43. It would be helpful if I could add. All right, and then minus 10. So now, it looks like a quadratic, however, you might notice that these 12x squareds will end up canceling each other out. And when I bring all my x's over here, so by subtracting the 26x, and that means I'm going to subtract the 13 over to the right side, I end up with negative 69x equals negative 23. And when I divide by negative 69, I get x equals 1/3. Now be careful. Right up here in this denominator, look what would happen if you plugged in a 1/3. You would end up dividing by 0. So this guy ends up being an extraneous solution. And since we have no other solutions, there is no solution. And that is the lesson on 9.6. Your next task is to do 9.6 practice and 9.6 bookwork. Good luck.